VRF, right? I'll try to configure it without VRF, and then I'll let you know that okay, what could happen if we implement it without, right? Or like what are the disadvantages that we can face over here, right? Without VRF. So first of all, I have to configure this core, understand, and I'll be doing configuration only for Microsoft customer first of all, and then later on I'll be doing configuration for customer Yahoo. And before going to configure customer edge routers, these are customer edge routers like this is, and this is customer edge router 2, right, for Microsoft. This is on in Gurgaon location actually, and this is in New York location, and this is London UK location, and this is Paris location for Yahoo, right? So Yahoo is established in London and Paris, and in both locations they have taken one MPLS connection actually from the same service provider. Right now here in CCI routing and switching, we are not talking about, like, it is also possible to take connections, MPLS connections from different service providers in different environments at different locations, right? That is also possible, but here we are just going to cover this part only of MPLS, right? So I will start from core, and this is British Telecom, right? British Telecom's network, and internally they will be running BGP AS 100, that is public AS. Whereas if we configure BGP for customer, then at the end of customer we will be using private AS, not public AS, right? And internally we will be using OSPF area 0 here for this British Telecom, right? So OSPF must not be enabled on customer facing interfaces. Like here customer facing interfaces are fast Ethernet 0 by 0, 0 by 1, and on R3 as well 0 by 0 and 0 by 1. Then I'll be using this OSPF for internal connectivity only, right? Because we will require to form indirect neighborship in between R1 and R3, because these two routers are working as provider edge routers over here, right? So to form BGP peering between two PE routers which are indirectly connected with each other, right? So it is mandatory that they must be reachable to each other. So we will form reachability between them with the help of OSPF over here, right? That's why here I'm running this OSPF, right? So let's start it now. This is R1. We loop back, and then let me move on R2. S1 by 0, this is 12.1.2. S1 by 1, this is going to be 23.1.2. Then loop back, right? And then finally this is what? R3. S1 by 0, this is going to have an IP address of 23.1.3, and the loop back is what? Any problem? Let's implement OSPF first. Router OSPF1 is very simple, right? Router ID is going to have, let's say, and then go to interface, loop back 1, IP OSPF1 area is going to be 0, then serial 1 by 0 is also going to use area 0. Similarly on R2, router OSPF1 router ID is 2.2.2, say network 000 with using single command, right? Area is going to be 0, because we know very well that R2 is having its all interfaces in area 0, right? And then finally R3, say router OSPF1 router ID is going to have, it's going to be 333, and go to serial 1 by 0, say IP OSPF1 area is going to be 0. Similarly loop back of R3 will also be part of area 0, right? On R1 show IP route OSPF, we must be able to reach now loop back of R2 as well as R3. Just wait for a moment, it will start receiving the loop back of R3, right? So it have started. it has started now to receive loopback of R3 as well, right? This is the loopback of R3, which means now R1 and R3 would be having reachability with each other, right? Now we have to enable LDP as well, which means MPLS in the core, right? To enable MPLS, it is very simple, as I told you before as well. MPLS LDP autoconfig within OSPF. So on all those interfaces where OSPF is running, LDP will get enabled, right? So now you can see show MPLS interfaces, right? So it will show you that serial 1/0 MPLS is running. Similarly on R2, I'll be saying MPLS LDP autoconfig, right? Similarly on R3, I'll be saying OSPF1 MPLS LDP autoconfig. Fine. So after configuring now LDP on all devices, now we must be able to see that okay, it is having LDP pairing with 2 to 2. Yes, it is having, and R2 is having with both of them. Yes, it is having, right, with both of them. Show MPLS show MPLS forwarding table. So now you see what is the level to reach 333. This is similar to previous class as we discussed, right? And now it knows very well that how can it reach this 3333, and to reach 333 which label will be in use, right? So we are already done with it, right? We have already configured this MPLS now. Now the point is, I'm gonna to use here like RIP in between Microsoft CE and, you understand, P router. P is R1, right? This is P1, and this is what, P2, right? So between P1 and Microsoft C1 Neox site, I'll be using RIP. So let's configure RIP now, right? So let me have the console of R1, and on R1's F0/0 IP address is going to be now, let me know, 1.2 on slash, let's say 30 itself. No shutdown. Then let's have the console of Microsoft C1. Fine. Interface F0/0, that is going to have an IP address 1.1 on slash 30. Then loopbacks will be having like 1.1.1 to 5.0 network, right? Sorry. Loopback 3. Oh my god. Three dot 1, 4, 4.1, 5, 5.1, right? Say router RIP version 2, auto summary network. Any problem? Then let's move on P1, that is router 1, right? Even we can allocate its host name as P1, right? And now you can see router RIP version 2 node of summary and network is going to be 1.0, right? Now you can see show IP route RIP. It must receive prefixes coming from customer edge 1, Microsoft customer edge 1, with the help of RIP. Just wait for a moment. Yes, it has received them, right? And this time we are not going to redistribute this RIP into OSPF. However, we can do that. But if you do that, might be possible that you are receiving like thousands of prefixes from your customer, right? Then it's gonna to be a big problem for you, right? Because you cannot redistribute 1,000 prefixes into OSPF, you know, in any IGP, right? So it will be better for you to configure BGP in between PE routers, right? So now I'm going to configure IBGP peering between PE1 and PE2. For doing that, router BGP 100 say neighbor 3.3.3, remote AS is going to be 100 itself, say neighbor 333, update source is going to be loopback 1. Any problem? Similarly, move on PE2, let's allocate its name as PE2, right? And then do one thing, say router BGP 100 say neighbor 1.1.1, remote AS is 100, neighbor 1.1.1, update source is loopback 1, and that's fine. That's what we needed to configure, right? Now BGP peering must come up, right? Yeah, it has came up now. Now you can do one thing, you can redistribute RIP into BGP, right? So we are already within BGP, inside BGP, right? So now say redistribute RIP. You understand? Now all those prefixes must be available in its BGP table. Yes, all of them are available over here, right? And you know very well now that BGP will not update its next hop address. Just wait for a moment. Let PE1 define this path as best path. Once it will define this path as best path, now it will start advertising them towards PE2, right? However, we could use let's say I want to just redistribute only 10's prefix, not that prefix which is running in between PE and C. And in most of the cases you will see that that prefix that network will never be advertised into BGP, which is running in between PE and C in most of the cases, right? So this time I'm going to advertise, sorry, to redistribute only 10's prefixes into BGP. To do that, I can use route map, right? So I will say IP prefix list CCIE permit 10.1.0.0/21 greater than equal to 24 less than equal to 24, and then we can create a route map redistribute red permit 10 match IP address prefix list, that is CCIE router BGP, that is 100, say redistribute RIP, right? Route map name is red. Any problem? Now you check out its BGP table. Show IP BGP. Show IP BGP. Yes, all of them are now best, and only those 5 prefixes are redistributed, right? And now you must get all these prefixes available in the BGP table of PE2 as well, right? Because it is having pairing with that. But yes, all of them are there, but none of them is best path, is defined as best. You know why? Because their next hop is not reachable, because by default IBGP does not change its next hop address, right? By default. To do that, now on P1 we can say router BGP 100 that neighbor 33333 next hop self. Once you will configure this command, now this problem will get resolved. You see, right? And now we have to configure EIGRP between Microsoft CE2 and PE2, right? So interface F0 by 0 is going to have, sorry, yes, it is 0 by 0. IP address is going to be now 2.2 and on /30 itself, right? Any problem? Then let's have the console of Microsoft CE2 as well, and we will configure that. F0 by 0 is going to have an IP address of 2.1 and slash, right, in loopback 10.1.6.1 loopback 2 7.1 loopback 3 8.1 loopback 4 9.1 loopback 5 10.1. right? And now we are going to configure EIGRP 100 node assembly network. Move on P2, say router EIGRP 100 node assembly network. Show IP EIGRP neighbor. Yeah, the queue count is now clear, which means neighborship has came up successfully, right? And now prefixes won't go from BGP into EIGRP, and if you want, then you have to perform redistribution once again. So now this time let's redistribute BGP back into EIGRP, so that all 10 prefixes, I mean all prefixes coming from New York site will be available at Gurgaon site. So say router EIGRP 100, say redistribute BGP 100, right? Metric is going to be now 154402551 and 1500. That's fine, right? And now you must be able to see all of them onto Microsoft CE2, right, which is located at the Gurgaon location. So IP route, you must be able to see all of them, right? No, of course no. All of them are not there. None of them actually, right? So we can move back again on P2 and then we can check show IP EIGRP topology table, right? So even in topology table they are not available, right? which means that redistribution was not done successfully. So remember that by default BGP does not redistribute internal prefixes into IGP. Internal prefixes, which means that which are received from its IBGP neighbor. And if you wanna really do that, then go to PE2 itself and then say router BGP 100 and then say BGP redistribute internal, that we skipped during BGP, right? So this is the use of BGP redistribute internal command, right? Once you will put it, now you will see on PE2 itself, show IPICRP topology. Here you will get to know that okay, it is having now redistributed prefixes, and definitely this time you will be able to see them onto CE2. You see, so remember that this is the default feature of BCP, that it does not redistribute internal prefixes into IGPs. And if you want to force your BCP to redistribute internal prefixes into IGPs, then you have to put that command within BGP, inside BGP, that BGP redistribute internal, right? Just give me a second, please. Fine, so Microsoft CE2 has received now all these prefixes, and all of them are coming as external prefixes over here, right? And similarly, we have to perform on PE2 as well. Like by default, prefixes won't go from EICRP back into BCP. So IP route EICRP. So it is receiving all these prefixes 6, 7, 8, 9, 10, right? And you won't be able to get them into BCP because you haven't redistributed them into BCP. So for doing that, again, I wanna redistribute only and only 10 prefixes, right? So to do that, actually, I'll be saying that IP prefix list, that is CCIP, right? Permit and 10.1 dot. First of all, 4, 5 will be there, which means I can take 10.1.0.0 slash 20, right? All of them will come, I think so, right? Greater than equal to, less than equal to 24. Then say route map sorry, route map red permit match IP address prefix list is CCIE, right? And then router BGP, that is sorry, redistribute EICRP 100 and route map, that is red, show IP BGP. You see, right? All of them must be available now on PE1. Yes, they are, but next stop is not visible. So once again, now you have two options: either use next stop self or use route map. So I'll be using next stop self only. Router BGP 100, say neighbor 1.1.1 next stop self. Once you will configure this command, that problem will get resolved. Best and show IP route BGP. Check it out that it has received all these prefixes coming from 333, but now it won't give it to rep. So once again, say router rep, say redistribute BGP, right? Redistribute BGP, that is 100, and metric, let's say it is 5, because the metric you have to specify in hop count, right? So on Microsoft CE1 now you must be able to see all of them. None of them was redistributed into rep just because of BGP rule, right? So once again, move on PE1 router BGP 100, say BGP redistribute internal. Once you will configure this command, now you must be able to see all of them available on. Yes, and now you see you can ping 10.1.10.1, right? When source is on loopback, because if you are not putting your source as loopback, you won't be able to ping it, because it does not have reverse path. You can reach destination, but destination does not have reverse path, because you didn't advertise the network running in between Microsoft CE1 and PE1, PE and CE, right? So now you can put your source as loopback, right? And now it will work fine. So the lane users will start communicating with each other, right? So there is no problem. You can configure MPLS even without using VRF as well. Even we configured it before, right? But what if in case Yahoo is also using same prefixes now and you are not using VRF? If Yahoo is also using same prefixes like here, now what will you do? Of course it won't work, right? It won't work. And that is why we are required to have VRF. And that is why we have to integrate now VRF along with MPLS. This is the reason. Because they can use same prefixes. I mean, different customers can use same prefixes. At that moment, you won't be able, I mean, this MPLS won't be able to segregate them. So to segregate them, actually, now we have to use here VRF. And we are going to use that now. Fine, let's start it now. So first of all, I'm going to remove BGP from both ends. No router BGP 100. I will not require this iBGP peering anymore. No router BGP 100. Because now via global routing table, we will not perform anything, right? So now it's not required to form iBGP peering globally in between. I mean, for global routing table, right? Because you are not required to take prefixes from one device to another device from their global routing tables, right? So now I have removed BGP from both ends, and also I'm going to remove no router rape from PE1, and from PE2 I will say no router EICRP 100. I have removed that, right? I have removed all these things now. Let's move back again on PE1 and let's create one VRF for Microsoft customer, right? So say IP VRF. What? Micro? That's fine, right? Micro. RD is 1:2. I told you that RD is for route distinguisher, right? Fine. RD.
RD takes some by default value also.
No, there is nothing like default, right? So you have to allocate it manually. After allocating it, go to F0 by 0 and make it member of VRF micro. So say IP VRF forwarding and micro. It will remove an IP address from this interface. Say 1.2//13. Now you see show IP route. In global routing table, you won't be able to see that prefix which is running between PE and CE. But if you say show IP route VRF micro, you must be able to see that. Right? So we have created this VRF now. And if you want to configure now RIP in between P and C, then you have to configure RIP this time for VRF, right? So you have to say like I want to receive all the prefixes with the help of RIP. So you have to say router RIP and then address assembly IP v4 VRF is what? Micro. You understand? And then say version 2, not a summary, and network 192.168.1.0, right? And now you must be capable to see or to receive all the prefixes coming from Microsoft CE1 within VRF micro. So IP route VRF micro. Check it out. Yes, but in global routing table you won't be able to see anything. You see, there is nothing in global routing table. Now we have to take these prefixes from one PE to another PE, right? From one PE to another PE, provider edge, with the help of BGP, right? And this time we are going to configure MPLS VPN, right? So for doing that, you need to configure router BGP. You understand? 100. Say no BGP default IP v4 unicast. Any problem? Router ID, if you want to configure it, then you can say BGP router ID is what? 1.1.1. Any problem? And then here we are not going to create any VRF for IPv4 unicast global global address family. No, I'm not gonna to create any address family for global routing table, right? Because it is not necessary to use IBGP for internal network because we are already running OSPF over there, right? So I'll be simply saying which is I will be configuring only that thing which is required for us over here, right? So I'll be saying address family VPN because we have to take these prefixes via VPN from one PE to another PE. If you are using VPN v4, then it is VPN v4. If you are using IPv6, then you have to say VPN v6. Unicast, fine. Address family VPN v4 unicast, right? Your neighbor is okay, fine. Before moving in router mode itself, you have to say neighbor 3333 is remote AS is what? 100 neighbor 3333 update source is loopback 1, and then address family VPN v4 unicast enable 3333 and then activate it. That's the only thing that you need to do, right? Within the VPN v4 address file. This is MPLS VPN actually. Actually, MPLS VPN is nothing, and it is nothing like that you will be configuring VPN within MPLS. No. Actually, you are configuring VPN in BGP, but you will call it MPLS VPN. Then go to R3, another P2, router BCP 100, no BCP default IP v4 unicast. You understand? And after it, say neighbor 1.1.1, remote AS is 100, say neighbor 1.1.1, update source is loopback 1, and then go to address family VPN v4. You understand? Unicast, and then say 111 is what? Activate. Now you will see that VPN v4 neighborship will come up in between PE routers, right? So you will simply require to configure VPN v4 neighborship between PE routers, nothing else. And this VPN v4 neighborship is something like trunk port, and one VRF is same as one VLAN access port. Are you not getting my point? One VRF is same as one access VLAN, and this VPN v4 neighborship between PE routers is kind of trunk port. Like traffic from all VLANs will be allowed through trunk ports. Now prefixes from all VRFs will be allowed through this VPN v4 address family, VPN v4 neighborship. Now it can carry prefixes, not traffic, say prefixes from different VRF. I mean to say from with different customers. So it's kind of trunking now. So now let's move back again on PE1. I simply did this configuration. You see, nothing else. I simply moved into router BCP 100. I disabled default address family. I configured router ID. I configured address family VPN v4. And before that, I configured neighbor update source, and then I moved back into VPN v4 address family, and then I simply activated it. Right now, you see, you check out its running config. Do show run pipe section router BGP. Check it out. That what is running config now of BGP. This is the running config of BGP now. I simply created VPN v4 address family, and I said activate, but it has already said send community extended, and that's mandatory. This is mandatory. However, I didn't configure this command. It came up automatically. So in BGP, it will, this command will configure automatically in case of VPN v4 address family. But make sure that if they have removed it from troubleshooting, then you have to add this key. You have to add this command, and I'll let you know that why is it mandatory. Right? Even you didn't configure this command, but remember that if your router is having VPN v4 neighbor, and then after you created any VRF onto that router, it will create address family for that VRF automatically. That's what it did. It has created address family for VRF micro automatically. So it will create it automatically now. Similarly, you can find on on P2, right? You can also look at the BGP configuration of P2. But here nothing like address family VRF, right? Because we haven't created any VRF onto P2. It doesn't have any VRF available, right? Let's move back again on R1, P1, right? We have done it now. Prefixes are coming into VRF, right? With the help of RIP. We need to take them into BGP. You know very well, without redistribution, it is not possible. Without redistribution, it is not possible. If you are sending any packet from one computer to another computer, then it is mandatory to allocate source IP and destination IP. Why? Let's take an example of destination IP only. Why? Why do we allocate destination IP address? So that it can be verified that who will be receiving this packet, right? Otherwise, anyone can receive that packet, right? So to deliver that packet on an appropriate destination only, we are having destination IP address. Fine. If you are sending any post via post office, it is mentioned, it is mandatory to mention to, right? To, I mean destination address. And if destination address matches at the time of delivery, then only postman will deliver that post, right? Otherwise, it won't deliver that. Are you getting my point? Similarly, now you are taking prefixes from customer and putting them into VPN. And you know very well that via this VPN you will be carrying prefixes coming from different customers, right? From a single VPN. On far end, how will you decide that okay, these prefixes are belongs to Microsoft and these prefixes are for Yahoo? How? So for that purpose, we must have some identity, right? For that purpose, we must have some identity. So for that purpose here in MPLS, in VRF, we are having route target value, import route target and export route target. Are you getting my point? Because VRF names are locally significant. VRFs are locally significant. Let's say you are exporting from VRF into VPN, right? So at the end of far end, you will be importing them from VPN into VRF. Are you getting my point or not? See, right now prefixes are available in the VRF of P, right? You need to take them from VRF into VPN. That is called exporting. You are exporting them, right? That's called export. Then at far end, you will be taking them from VPN into VRF back into VRF, right? From VPN back into VRF. And to take them from VPN back into VRF, you will require to import them. So whatever ID you will use for export at P1, you have to use same value, same identity value during importing them at the end of P2. Are you getting my point or not? Hello? No? Export, import. We are exporting them. We will be using some identification value. Similarly, we have to use same identification value at the time of importing. Otherwise, you won't be able to import them from VPN into VRF. So for that purpose, here we are having route target values, RT. And RT is also specified in form of RD value, like 16 bits colon 16 bits.
RD works locally.
RD, I never said that. Don't worry. RD is different thing. RT, and right now I'm just discussing only RT, route target. Forget about RT. I'll let you know that whether it is locally significant or what is that actually, right? So I didn't allocated any route target or route target import or export. If you do not allocate export RT, then you will not be able to import them. So before taking your prefixes from VRF into VPN, it is mandatory to allocate export RT at the end of this, right? So go to IP VRF, that's name was micro, say route target. You can say both, so it will work for both importing as well as exporting, but this time I want to allocate it only for export. Let's say it's that you allocated is what, 1:2. It can be same as RD as well. It can be same as RD as well, but this time I have taken it as 1:2, right? This is for exporting, right? On P1, so IP VRF detail, check it out. What is that? RT route target. Yes, that is for exporting, right? That we allocated 1:2. And now if we look at P1, so we have to redistribute prefixes from rep into BGP now, right? Which means that we have to take prefixes into BGP now, right? To send them via VPN. So for that purpose, router BGP 100, address family IPv4, VRF name was micro, and this address family was already created, right? And inside this address family now say redistribute rep. Once you will redistribute them, it will get redistributed into BGP now. But for this VRF only. However, it will go through VPN now, right? It will send them via VPN now, right? Now you see, if you say show IP BGP, you won't be able to see anything, because I told you before, I told you earlier on that one VRF is equal to one VPN. Now you see, show IP BGP, VPN, V4 all enter. You see, this is route distinguisher 1:1, and VRF is what? Micro, and in it, it is having all these prefixes, right? Even you could see all of them in this manner as well. VRF micro. It will show you only those prefixes which are in VRF micro. Understand? This is happening on P1. And now you must be able to see them. And one more thing that I would like to show you over here now. I just performed this redistribution, which means that prefixes moved from VRF into VPN, right? At same moment, show MPLS forwarding table. See what happened over here. It created VPN label for all those prefixes which entered from VRF into VPN. It created labels, that's called VPN label, for all those prefixes which entered Is there any problem now? So it has created local labels for all of them, right? Are you getting my point? Now let me capture this link. This RT route target will always go in the form of extended community. It will be attached to BGP updates in the form of, and if you do not enable that command that set extended community for this neighbor, right, within VPN v4 address family, then this RT value will not be forwarded along with prefixes, along with BGP updates. That is why I said that this is really mandatory, right? Now let me show you. If I'm on P1, right? Say clear IP BGP VPN v4, VPN v4 unicast and BGP VPN v4 unicast star star. See, BGP has given update packet from 1 to 3, right? So now you can open this packet. Oh my god, just stop it. Right, open it. Check it out. BGP updates. It's having path attributes only. Forget about it. Next one. Oh, path attributes. Yes. So if you do not allow this extended community, you understand? And you can see that what can happen. and this is multi protocol. Yes, these are prefixes. RD is also going along with updates. RD is also going along with updates, but not in the form of extended community. And you see labels are also VPN labels, right? And this is what bottom label. This is not top label, because LDP label will be your top label. This is bottom label, right? So whatever it created, P1 created labels, it is giving that information to its neighbor now. And neighbor is what? 333. In update, in the form of updates, you see that it is giving complete information. You can open it. This is multi-protocol now, right? And I think this is bytes, 112 bytes. You know why? Because it is having route distinguisher, that is again 32 bits long. 32, that is 64, plus 32 is, I think it will include RT, and total it is having 112 bytes long, this NRI this time, prefix length, you see, because it is including now everything. So you see, just try to understand it. What I did, first of all, I've configured VPN v4 neighborship, right, in between PE1 and PE2, right, and then later on I went on PE1 and I created VRF, right, and I redistributed RIP back into BGP. So prefixes were exported into VPN v4, right? So at that moment, when we exported from VRF into VPN, at same moment P1 created some VPN labels, that is called BGP labels as well. Show MPLS forwarding, and it will be having all of them in its LFIP. It will be having all of them in its LFIP. You can see that outgoing interface is F0 by 0, next hop is 1.1, right? So these entries are available in its LFIP, and it will be giving these labels to its IBGP peer, VPN v4 peer, right? And that is R3. For R3, these labels will become outgoing labels, right? Because these are local for P1. Hello? As per the rule of labels, for P2, these labels will become outgoing labels. Let it be. I'll clear it. Don't worry about that. Have you understood RT, route target? RD was just a kind of distinguisher, right? It was just kind of distinguisher, and I will let you know that why is it necessary for us, right? Just wait for a moment. Fine.
Also, when we redistributed reference to BGP,
Yes.
it by default had put it in VPN before.
Yes, of course, it will put it.
So, if we have multiple VRFs,
Yes.
PE,
You just need to redistribute them into VRF only, into their appropriate VRF.
IP version 4 VRF, right?
Yes.
So VPN v4 is only for
It's kind of trunk.
yeah, only for activate and
Ye-
extended community.
Yes, that's the only
so
thing.
by default, whatever is coming in VRF, it is getting
Kind of VPN. That's why I said that one VRF is equal to one VPN.
One VLAN.
Yes, kind of VLAN. Yes,
And everything would go in VPN.
VPN
Whatever
v4.
is
Exactly. And that is why we are using here RD. You know why? RD is same as
VLAN ID.
RD is same as VLAN ID that is used during tagging, VLAN tagging. Whenever traffic goes through the trunk port, it performs tagging, right?
Right.
So whenever prefix is coming from different customers into different VRFs, right? Whenever those prefixes, might be that you are receiving same prefixes from different customers, right? But they will go through the same VPN v4 address family, VPN v4 neighborship, right? Then how will it be possible for VPN v4 to segregate them? Route target, not route target, route distinguisher. Route target will be responsible that who will be receiving them, who will be importing them.
So if we have multiple locations,
On both locations, you can have different RDs. No worries. Yes. I'm gonna to do that. See, hello guys. Do not talk, please. Now let's move on R3. Right now R3 doesn't have anything. It doesn't have anything over here. You see, show IP, BGP, VPN, v4, all doesn't have anything because it is not possible to import them, right? It is not possible for it to accept all those prefixes. Even I can say debug IP, BGP, VPN, v4, and unicast, and was that updates. Fine. Say clear BGP, VPN, v4, unicast, star in. Check it out. Wow. Because you didn't configure VRF, you didn't allocated RT route target. So it is not possible to import them now, right? I get my point. It is not possible to import them. That is why you are not able to, get them over here. So community is coming as 1:2, but you are not able to receive them because you haven't configured anything, right? Now I'm gonna do that. I will say IP VRF. Name is micro. Even it's not mandatory to use same name. I will use mic because VRF name is locally significant, right? Now you have to allocate RD. I'm allocating different RD now. This is different RD, right? And then I'll be allocating route target. It must not be different. And route target for what? Exporting or importing? And this import route target must be same as that you used over there during exporting them. That is mandatory. And that's fine because it will create address only now automatically for this VRF, right? Because it was already having a VPN v4 neighbor, right? Sorry. Yes, it has shown us from here. See, mic address family. It has been created by it automatically, right? And now you will see that it will start receiving all those prefixes, right? Let me do one thing. Let me say clear unicast, right? And this time it will accept them. And to see them, we have to run this command. Show, you see, on P2, right? Show IP, BGP, VPN, v4, either all. It will display the configuration of all VRF, right? Right? And if you say show IP, BGP, VPN, v4, VRF is what? Mic. Sorry. It haven't entered into VRF yet. It will take some time. Just wait for a moment. They are present now on P2 for VRF mic. Even if you say show IP route VRF and next hop has been modified auto. So in VPN v4 even you are not required to define next hop self command as well. Next hop self is predefined. However, it won't show you in running config, but it is predefined over there. So don't get confused. It is not like normal IBGP peer. This is VPN v4 peer, and next hop self is by default there. Understood? All of them are available now in its. Now let's talk about RD. I used different RDs. Show IP, BGP, VPN v4, all enter. If you do not use same RD value on both ends, it won't create any problem, but it will create duplicate entries in BGP table. That is the only problem. This is the only problem if you are using different RDs on both PE routers, that it will create duplicate entries in BGP table and it will consume more memory. Right? This is the only thing actually that will happen. So it is good to use only same RD on both ends. So it won't create, see what I said, you can take it same, you can take it different. So we can't say that it is locally significant. You know why? Because it is going along with BGP updates, right? It is going, but in other words, we can also say that it is locally significant because we can take different RD on both ends. So I hope that now difference is clear.
So it is showing best for both.
Yes,
parties.
of course, it will show you. But in routing table, it will install only for this VRF.
For yeah. Because it is matching out target.
Exactly. Right? So this is the thing actually. This is the only problem that you can face if you are using different route distinguisher on both ends.
But VRF name can be different.
Of course, VRF name can be different, but RT, route target, that must be like as per export and import. Not same. For export and import, you can use different on a single P. But like if we discuss it in terms of both ends, right? So at one end you will be exporting them, on another end you will be importing them. At that moment they must be, I mean that value must be same. But on a single device, export and import can be different. Like I am exporting with different RT and I am importing with different RT. RT, route target.
Can we have multiple
RTs, of course, for
one
exporting, for
VRF?
importing. Yes,
No,
of
no, for
course.
one VRF.
Of course,
Multiple.
I'll show you. We will do all that thing actually. Like we will perform all those practicals in where we will require to configure multiple route target values. Don't worry about that. I'll teach you that how to perform route leaking between customers. Fine. Now let's configure same RD on PE2 as well. RD, route distinguisher, IPVRF, that is mic. Say RD is now 1:1, same as R1, but it is saying that no. Say no, RD 2:2. Now it has scheduled it for deletion. Then say RD is what, 1:2, sorry, 1:1. What is it saying? Yes, it will take some time, right? Because now it has to converse the whole process of VRF. Once it will accept it, which means that everything has changed now, but it will take some time now, which means that it has been updated now, right? Now you see, show IP, BGP, VPN v4 all. So it is having only one entry now. You can get all those prefixes available in your VRF. What? Just wait. It will take some time to put routes into a routing table, but definitely you will get them, right? Now I told you that in BGP table it will receive that VPN label, right? BGP label, because that label was generated by BGP itself, right? So this time on P2, if you look at show IP, BGP, VPN v4, VRF, that is what? Mic, and then prefix was 10.1.0. Check it out. Oh, just wait. It will come. It has arrived now. Even you can look at show IP route. VRF is what? Mic, right? So you must be able to see that. Right? And then you can also look at the output of this. You see, this is the way to see prefix, BGP prefix coming through VPN, right? So extended community is what? 1:2. That is coming along with this path, right? And MPLS label in out. So outgoing label is what? Which means local label at the end of for 10.1.0 is what? 21 local label, and that is why for P2 it has become now outgoing label. However, it won't show you here in forwarding table. It won't show you in forwarding table because it is receiving that prefix within the VRF, right? Within the VRF. And also you know very well that whenever it will receive any packet coming from Microsoft customer, right, this PE2, it will perform lookup in its fib or in its lfib. Fib, of course, because it will receive unlabeled packet from there, right? So you see that R3 will perform lookup in its fib in VRF mic. So you say show IP SAP VRF mic for which prefix? Wow. It will tag two labels 16 and 16 is what? Top. 21 is what?
VPN level.
VPN label. This is what? VPN route head. So you know everything is in very simple manner. Everything is step by step, right? Routes are available on R3. Now you need to take them up to Microsoft CE2. So you have to configure now EICRP for VRF mic. So you do one thing, move on R3, and on R3 now you need to do like go to F0 by 0. So IP VRF forwarding is what? Mic, right? IP address is going to be now 2.2, right? On slash. Any problem? Now you say router EICRP 1, address family IPv4 VRF is what? Mic. Say autonomous system 100, no auto, summary, and network, tell me 2 dot neighborship will come up. But routes can't move from BGP into EICRP, right? So this time you can look at here, so IP route VRF is what? Mic. So some routes are coming through EICRP and some of them are coming via BGP. So you need to take BGP prefixes back into, and this time you will not require to configure that command BGP redistribute internal, because if you are receiving from VPN v4 neighbor, then you can give them, I mean you can redistribute them into ICP very easily. That rule does not apply for VPN v4 neighbor, right? And fine. So now let's perform RAID distribution from BGP into RAID. Sorry, EICRP. So say router EICRP 1, address only IPv4 VRF was mic, and then say redistribute BGP 100, and then fine. Now you can look at the topology table of EICRP like this. So IP EICRP VRF name is what, and then topology. So you must get them. Yes, all of them are there. Redistributed, right? Redistributed. But you could also use route map name. Do you remember? Route map name was. So this time it won't redistribute all of them, right? Sorry, here not here actually. At the time of whenever you will redistribute EICRP back into BGP, at that moment you will redistribute it. Do one thing. Redistribute without route map, right? But here at the time of P1, when you redistributed them onto P1, right, use route map. Where is that? Yes, and redistribute rep route map. That name was. Now you see show IP BGP VPN v4 all. So only those 10 prefixes, right? Similarly, you can move on R3. You will see show IP BGP VPN v4 VRF is now what? Mic. Or you could say you could see for all VRF as well, right? But this time there is only one VRF, so it will show you information about that VRF only, right? Now prefixes must move into EICRP. So on Microsoft CE2 you must be able to see them. Yes, all of them are coming now, right? Only 10 prefixes, right? Similarly, I'll redistribute this EICRP back into BGP. So right now on R3 you do not have anything in its lfib, right? Like 10.1.6.0, 7.0, right? But this time say router BGP 100, say address from the IPv4 VRF name is what? Mic, say redistribute EICRP. That's fine. And now you look at show MPLS forwarding table. See, it has generated VPN label for all these prefixes, right? But use route map for that. Again, I've forgotten to configure route map. That is right. And show MPLS forwarding table. Only for 10 prefixes, right? You understand? And then after, show MPLS, show IPBCP VPN v4 or enter. So all of them are available now here, right? Similarly, you must get them onto P1. Show IP BGP VPN v4 on. So for VRF, not yet. You know why? Because we didn't configure export RT over there, and here we didn't configure import RT. So you have to, we have to configure that, right? Otherwise, prefixes won't come from there to here, right? So you do one thing, say IPVRF, that was my, say route target for exporting is what, 2 is to 1. And here at the end of P1, say IPVRF is what, micro, route target for importing is 2 is to 1. And now you must be able to see all of them over here, right? You have to do it, and after something, it has received all the prefixes coming from 333, right? But and also show IP route VRF is what, micro. You must be able to see all of them. Yes, all of them are coming now, 6, 7, 8, 9, 10 from 3333, right? And yes, that's fine. And then you have to use it for RIP, right? So say router RIP at assembly IPv4 VRF, that is micro, say received BGP 100, and then symmetric is what, 1, right? And now you must be able to see all of them on Microsoft C1 as well, right? All prefixes must be available. Yes, all of them are available now, right? And you can try to ping with 10.1.6.1 when source is loopback1 and repeat is 1000. Traffic is going through, right? And how traffic is moving from one location. Fine, you see now how traffic is going from here to there, right? See, customer as one, like whenever you will try to communicate with 10.1.6.1, it will perform lookup in its routing table, right? So it will come to know that, okay, 10.1.6.1 is reachable via 1.2. So it will forward this traffic towards 1.2. P1 will receive it now on F0 by 0. And F0 by 0 is member of VRF. Tell me, micro? Fine. So it received unlabeled or labeled packet? Unlabeled. Again confused. Labeled or unlabeled? Of course unlabeled, because Microsoft C1 didn't attach any label. So P1 is going to receive unlabeled packet, will perform lookup in its SEF table, fib table, right? Fib for VRF micro. So IP SAP VRF micro 10.1.6.0. Check it out. It will impose two tags now, 17 and 23. 17 is to reach next hop, and 23 is what, VPN label, that is bottom label, and will forward this packet out from serial 1 by 0, that is point to point interface, right? Are you getting my point? It is same as like we did in static routing, like exit interface, next hop address. Do you remember? We take traffic from VRF into global routing table. Similarly, now traffic is going from VRF into global routing table. Global, via global interface, you can say, right? Because S1 by 0 is not part of any VRF, right? So now traffic will be received by R2, but this time it will receive labeled packet. And it will open top label. Top label was 17. Show, it will perform lookup in its l3vpn now, right? Show MPLS forwarding table now. You see, it is what? So it will pop tag. It will remove this 17 and will forward it out from S1 by 1. So it will remove that tag and will forward this packet out from S1 by 1. But it haven't removed to bottom label. It removed only top label. Now it will this packet will be received by R3. Labeled or unlabeled? Labeled again, not unlabeled, because bottom label was still present, right? So now you see show MPLS forwarding table. So it will also perform lookup in its l3vpn for label number 21, and 21 was, sorry, not for 21. I think it was 23, right? Hello, you forgot, right? 17, 23. So 23, right? So 23, it performed lookup in its l3vpn. Came to know that it has to forward this traffic out from F0 by 0 without any label, unlabeled, right, untagged, and the next hop is going to be 2.1, and once again traffic is going from VRF into, sorry, from global to VRF now. So it's very simple to understand that, okay, where to send this traffic, right? It is very simple. Routers are taking decision based on available information only. Is not it? So this is the concept followed by mplspart.
But it is not mentioning VRF name in this.
Of course, it will not. It will not mention, right? And it does not need, because ultimately it has to switch your packets based on labels only, not VRF.
No, the exit one, the
Uh,
2.1.
it is having exit interface and next to purpose. That's fine.
And that is set for VRF.
In similar manner, now packet will be delivered onto CE2, right? It will respond back. R3 will receive that packet onto F0 by 0. It is a member of VRF mic. It will perform lookup in its fib of mic of VRF mic, right? So for 10.1.1.1. So say should I be SAF VRF mic for 10.1.0. Will impose 16 and 21 and will forward it out from S1 by 0. R2 will receive it with label number 16. It will pop that. Will send it out from S1 by 0. R1 will receive that with the label 21. So MPLS forwarding table. If it receives anything with label number 21, will forward it out from F0 by 0 towards 1.1. Finally, packet will be delivered onto R1. So in this way, in this manner, packets are going from one end to another end. And now, in case if different customer Yahoo is also using same prefixes, it won't be a big problem for us anymore, because labels will be different for that. VPN labels will be different for that, and routers will switch data based on labels. Should I go to configure now this different customer Yahoo? Let's start doing configuration for this as well. First of all, move on PE1. On PE1 this time, create one VRF, which is Yahoo. RD you can take anything like 2:2. Route target for exporting I'll be using 3:4. Route target for importing I will be using 4:2. Let's say 3. Go to F0 by 1 IP VRF forwarding, that is Yahoo. IP address this time is going to be 3.2/30 itself. Any problem in it? No? Fine. Then we have to take console of Yahoo C1, and on Yahoo C1 F0 by 0 3.1 same prefixes, right? So what do you want to configure now? OSPF or BGP or what? This time, I mentioned OSPF, but let's configure something different. What do you want? BGP itself? Because if you use BGP, then you will not require to perform redistribution, right? So let's use BGP AS 65500 over here. BGP AS 65500, right? Move on, Yahoo C1. And say router BGP 65500 neighbor is 3 dot remote ASS and network, or you can say right? Move on PE1 now. You don't need to worry about it. It's very simple to configure it now, right? You just need to move inside the address family now, right? Address family IPv4 for which VRF? Neighbor is and remote AS is 65500. And this time you will see that prefixes will be moved from VRF into VPN automatically. Let neighborship come up and then I'll show you. Yes, neighborship has came up now, right? To see that, so IPv6, VPN v4 all, and sorry, not all. So IPv6, VPN v4 all summary. So it is having neighborship with 3.1, right? Remote access system of so IPv6, VRF, VPN v4, VRF is what? Yahoo. It must receive all the prefixes. Yes, it is receiving that. And show IP route VRF Yahoo. Check it out. It has received all of them from this neighbor. And also show MPLS forwarding table. It will generate outgoing, it will generate local level for all of them. See, same prefixes, but different label. VPN label will be different. You can see that. Exit interface and next hop addresses are also different. That's the beauty of it. Right? That's why we allocated different RDs to distinguish them. So that VPN, now BGP is generating different labels for them. Right? Now all these prefixes, you can see that now show IPv6, VPN v4 all. This is for micro, and this is for Yahoo. Same prefixes, but RD is different.
If they create the same label, then also there is no problem.
Why? Then how will it be possible to let's say that it received a packet with that label? Then how will it be possible to decide that whether send it out from this interface or out from this interface? Because based on labels now it will decide that what is the exit point actually, or which exit point has to be used. Is not it? Fine. Now let's move on R3, and on R3 also we have to create IPVRF, that is RD, and route target for importing is 1:2. Sorry. Route target for importing is 3:4, and route target for export I will be using 4:2. And then show IPVRF detail. Check it out. Yes, we have configured it. Right? It must start receiving prefixes in VRF Yahoo as well now. Go to F0/1 IPVRF forwarding, that is Yahoo. IP address is going to be now 4.2/13. Right? Then we have to take the console of Yahoo C2 as well. Configure it. Fine. So here I'm going to configure OSPF, right? It's not like necessary to use BGP only, right? We can use OSPF as well. In between PEC, you can use any protocol, right? It's not mandatory that on that end we are using BGP, so here also we have to use BGP. Nothing like that, right? So now on PE2, we must be able to see them, right? So IP BCP, VPN, V4, all enter. In VRF, yes, it has received them. See from, is not it? An outgoing label will be different this time, right? If you look at so IP SAP, VRF, mic 10.1.1.0, this is 1621. But for VRF Yahoo, check it out. This is 1629. Is not it? So it, however, traffic will be going towards the same prefix, but it will be using different VPN label, right? So that now another P can segregate that traffic. Is not it? Okay, just wait for a moment. Everything will get clear now.
But the other end really will segregate on the basis of root target.
Not root target. See, this root target is just for prefixes, but what for data? Root target is just for prefixes. Data is different and prefix is different, right? What about data? How will it be possible for PE1 to decide that okay, this traffic has to be transmitted out from F0 by 0 or F0 by 1? Because prefixes are same, destination IP address is same. I get my point. Yes, RT is used for prefixes, like we have defined different RTs, right? But what about data? Destination IP will be same. So how will it be possible for PE1 to decide that which exit interface has to be used to transmit data, to transmit packets, either F0 by 0 or F0 by 1? So it would be based on labels, right? So now PE2, I'm going to use OSPF router OSPF 100 VRF is going to be now Yahoo, right? Okay. What's this? What I created. Router OSPF. Sometimes see, I configure same command, right? But R for router was in capital letters, right? I think due to that only it was creating some problems. Router ID, let's say 100 or 10.10.10.10, whatever it is, right? Then say network 192 168, here we are running 4.2, right? Area is going to be 0. Yahoo C2 do show run interface F0 by 0. Fine, router OSPF 100 or whatever it is, it will pick router ID automatically, but we can make it like 10. And see area 0, I'm running here area 0, right? This is area 0, and I'm also running in the backbone area 0 itself, right? But these processes are different from each other, right? Show IP OSPF neighbor. Now we can look at this. It will elect DR and PDR, and finally it will move into full state, right? And then you can look at the show IP OSPF database. You see that for area 0 is different, and for process 1 it is different. For process 50 it is different, right? Processes are different from each other, so that now prefixes will not collide with each other, or will not be mismatched, or will not go from one process to another process. As you know that by default on a single router, if you are running multiple processes, then it is not possible to forward your prefixes from one process to another process without redistribution, right? So now you see that show IP route VRF, you see Yahoo. Some prefixes are coming with the help of BGP, and some of them are coming with the help of OSPF. Now you are required to redistribute BGP back into OSPF and OSPF back into BGP, right? So to do that, I'm going to say router OSPF, I think it was 50, VRF was, so redistribute BGP 100 subnets, metric type 1. That's fine. right? Go to BGP, router BGP 100, address family IPv4, VRF name is Yahoo, say redistribute OSPF 50, VRF name was Yahoo, right? That's fine. So IP, BGP, VPN, V4, all. We must be able to see all of them. You see? Yes. Same prefixes are there, right? Even on PE1 as well, you will get same prefixes now for both VRF. You see? Same prefixes are there, right? And now on Yahoo C1, you must be able to see all the prefixes coming from Yahoo C2. Yes, you are getting them, right? 6, 7, 8, 9, 10. On Yahoo C2, you must be able to see all the prefixes coming from Yahoo C1. Yes, you are getting them. And now you can ping with 10.1.1 when source is loopback 1, right? And how will you verify that? Okay, from you know, Microsoft CE1 you are accessing CE2 only, and from Yahoo CE1 you are accessing CE2. We will be using telnet now, right? So on Microsoft CE2 I'm going to use telnet, enable telnet, right? Enable password, Cisco line VTY024, password is Cisco, do show history. Just copy and paste on Yahoo CE2 as well. You understand? And move on now. Microsoft C1 and from Microsoft C1 try to take telnet of 10.1.6.1 when source is its source interface is loopback 1. Cisco. You understand? Cisco. Done. So Microsoft C2. And if you are accessing from Yahoo C1, say telnet with same IP 10.1.6.1. Source interface is loopback 1. Cisco. Is not it? However, both customers are using same prefixes. How traffic is going on? Based on labels. It's all about labels now. Now you need to revise this video by today itself, otherwise everything will be flushed out. Because it's all about the concepts, right? As I told you for customer Microsoft. Same like for Yahoo, whenever this P1 will receive packet coming received on F0 by 1 for 10.1.6.1, right? So it will perform lookup because this interface is member of VRF Yahoo. So it performs IP SAP, VRF Yahoo and 10.1.6.0. Check it out. What is happening? It is not showing, but it must have shown. No route, valid no route existence. What is this? P1 ping. It's working fine. It is not showing you, but it has shown you same like if I'm doing it for Microsoft, it is showing me this information. Same it has shown me for Micro VRF Yahoo as well. Because this time it is 1720, but at this moment it will be 17 and something different, right? Even you can look at here, show IP BGP VPN V4 VRF is what? Yahoo. You must have outgoing label over here, right? 10.1.6.0. What is this? was the problem? Okay. OSPF, right? /32 loopbacks. That's the problem. And I was taking 0 here, right? So make it 6.1 itself, right? Now it will show you. You see, outgoing label is what? 28. Right? You do one thing, move on Yahoo C2 and go to loopback. IP/OSPF network type is what? That's it. Fine. Now they will come on /24 itself, right? And then you don't need to specify. You see, with 0 as well, right? Only if you change your VRF name, let's say you made it micro. Now your outgoing label is what? But now it is, I mean, in case of Yahoo it is 33. That's what the difference, right? Same show IP Ceph VRF micro 14.1.6.0 for VRF Yahoo. That's what the difference, right? So VPN label will tell that which interface is the exit interface actually. And for LDP label, PHP is still going on. PHP penalty met hop hopping for LDP label. That is for outer level or top level. So this way your MPLS works, right?
How does route map work in the router? If you want to filter some maybe maps.
Import map, export map. Within the VRF you can configure export map, import map, where you can tell that okay, these prefixes should be imported or should be exported. You understand? So for that purpose you have import map, export map. Within import map, export map, you will be calling route maps only.
So like if I have multiple sites, like 4 or 5
Like
sites.
you are receiving so many prefixes, right? In VPN and in VRF you wanna import only some specific prefix, not all, right? Then use import map, not both. Import map, right? In import map you can tell okay, I wanna import only these prefixes from VPN into VRF. You are giving prefixes from VRF into VPN, but you wanna export some specific prefixes only, right? Use export
So
map.
if I have 4 sites with same customer, I should have route target same for all, and then
It's
deploy route maps on local PEs or CEs wherever, whatever filtering I need to do.
yes. You can.
So both ways. And since you took example of trunk and VLAN, so I have multiple PEs in service provider network. So by
All
default,
those P's will not be having direct neighborship, right? In provider network, what happens actually, like you will be having this kind of network, like hundreds of routers will be there, right? Like R1, R2, R3, R4, R5, R6. If P or all P routers will be having neighborship with also, total number of neighborship will be two, it will be huge, right? So what do they do? R1, R2 in core, they will be connected in this manner, like so that in case if any one of the physical link goes down, then there should not be any effect, right? Now it will be with this is P router, this is P router, this is also P router, this is P. They will make them route reflector. This is R1 and R2, right? They will be having IBC peering with this route reflector. That's it. So now if customer is terminating on P1, this is P1 and this is P2 or P5, right? Customer is terminating here. No problem, not at all.
no, that's fine. I understand that. So that's the peering
Yes,
part.
between RR and
Right.
these P routers.
But the PRF traffic, which is hitting VPN, so would it hit all the
No, it will be
PEs?
depending on the IGP now, because internally IGP is running. traffic will be forwarded towards the next hop address only based on labels. Just like here, R2 is forwarding traffic based on labels only.
No, in that example we took a different RD value, 1:1 and 2:2.
But in routing table,
we were getting both 1:1 and 2:2.
Yes.
On the other side.
Yes. But label will not get changed. Label will remain
Label
same.
will not get changed.
Yes.
So my question is, suppose in one PE we have say XYZ
Mm-hmm.
RDs,
Yes.
and in other side also I have XYZ and ABC also,
Fine.
and maybe
You cannot configure multiple RD. You can configure multiple RTs, but you cannot configure multiple RD.
no, for different VRFs.
Okay. Okay. Fine.
For
Fine.
different-
Fine.
So question is like in I'm where I'm coming from is from the concept of pruning. Like, do we filter VRF traffic from VPN?
No. Why? Why?
Because it would otherwise overload a particular PE. If suppose that PE doesn't need to get all those VRFs on that particular PE, because by default it would get everything which is being pushed into a PE, right? In a VPN.
But the point is, if that PE router doesn't have that VRF, it won't accept all those prefixes.
It will not accept, but it will accept in a sense.
Like it will not be having that.
If route target is not configured, then it will.
See, if there is no VRF, see, I told you, even here we proved it. From PE1, I injected prefixes from VRF into VPN, right? And I didn't create it, I didn't configure VRF onto R3, onto PE2, right? Till that, PE2 was not having all those prefixes. So that is why I'm saying that.
PE2 had that 1:1 and 2:2, both it was showing both.
RD doesn't matter. Route target must match, right?
No, route target is okay, but it is still receiving it. It is not kind of importing routes, but it was receiving.
No, it
those
cannot.
privileges.
It cannot. It cannot at all, based on RD values.
Okay. I'm not sure if I confused.
See, RD is just to distinguish routes. That's it. RT is just to tell whether you can have these prefixes from VPN into VRF or not.
No, that's
Do one thing.
That's right. Yeah.
Now relaxed, right? Just go through this video once again, because now we have covered so many things from